Nursing Chem Lab 2 and Lab 3. So Lab 2 has two parts. Part A, you're measuring the volume of a goggle box. The goal of Lab 2 is to figure out how good your instrument is. So you have a data table that looks similar to this, and for the goggle box, you're going to measure the length, the width, and the height. And I will give you fake data or somewhat fake data after the video. You have a couple tools to use. You have this silver meter stick that has three sides. Side A doesn't have any markings. So for example, if you're measuring the length of the goggle box, you have no option except you know it's less than half. Maybe it's a fourth of the meter, you don't know, and I'm only allowing you to record to the 10th decimal, so you can estimate 0.2 or 0.3 meters. Side B, if you are measuring the length, gives markings, if you see at the 0.1 meter, 0.2 meter, 0.3 meter. So if you were measuring the length, you are between 0.1 and 0.2, but you have to estimate to the 100th decimal. So maybe you would estimate 0.17 meters. So if you see recording the data, you would estimate. So here maybe you would say 0.2 meters, and here you would say 0.17 meters because you think it's close to the next marking, but that last digit here that's underlined is an estimate. You would do the same, thank you. You do the same for side C, except you're given half markings, and you would measure the length recording to 3 after the decimal. These are not very accurate compared to the meter stick, which has markings in the millimeter zone. So in the meter stick, you do the same thing, except you definitely know, for example, 0.1, and then the numbers would give you would know 0.17, and then maybe you're at the halfway between the 7 and 8, maybe you're at 0.175, and then you estimate one more, maybe it's halfway between two black markings, 0.1755. So the meter stick, the students recorded 4 numbers after the decimal. You would record the length, the height, and the width, and multiply all 3 together to get the volume and compare from very poorly marked side A to better meter stick, and you can see the volume measurements for the goggle box. Okay, so that's part A. I will give you some data for that later. Part B, you're comparing again bad glassware to better glassware. You are told in the procedure, drop your glassware, you're told in the procedure, measure approximately 75 milliliters of water into the beaker. You have markings at the 60, a line, and the 100. So I'm gonna go above the 60, but less than 80. That is the best I can do. I can record in my data sheet, and I can even do it here. I can record, I was told to do 75 milliliters. That is the best. I'm hoping that is 75 milliliters. Pour it into the 100 milliliter graduated cylinder. Okay. And then I look, the paint on the, actually a dark background would help. Give me 1 second. I have a dark calculator. We'll use the dark calculator. The paint allows you to see to the ones place. We definitely know the meniscus is at I'd say 63, but below the 64. So I definitely know 63, and I'm going to estimate between. So the 10th decimal I estimate and record 63.5. I say it's halfway between. That is better than the beaker. So that was part B. The last thing for part B is recording the temperature, and I will give you data, but essentially you can record using the thermometer. Now the thermometer goes once again to the 10th decimal, and you need to estimate to the 100th decimal looking at the red line on the thermometer. And I will give you data for this because it's not focusing. That's okay. Okay. How long is it so far? Can you tell? Okay, let's do lab 3. Lab 3 over here are a variety of unknown metals. They're a bunch of little pellets that cannot be measured using a ruler or a meter stick. Okay, so you would grab an unknown metal and record the unknown code that is written on the vial. You would then measure the mass of the metal, which you can learn how to do that in another lab. I already measured the mass of my metal. So your unknown code, let's say it was B, I had a code, B73. Mass of my unknown was I did 19.026 grams. Okay. So then the procedure says, in your 10 milliliter graduated cylinder, record an initial volume. The pellets need to be covered. So let's see. Between the 4 and the 5. Need a dark background. Above the, no, I'm below the halfway, so I definitely, looks like 4.3, and then I estimate the 100th place, so maybe 4.35 milliliters. So my initial volume is 4.35 milliliters. Okay, 4.35. I already know the mass of these pellets. I weighed them earlier. These are the unknown metal. I don't know what the metal is. I'm going to solve the metal by using the density. I have the mass. Now all of the pellets slide in. 3, whoa, 4. Careful not to spill. All right, now I re-record final volume. It's above the 6. Looks like 6 point, I'm gonna say 10. 6.10 milliliters. So then, take 6.10 minus 4.35. 1.75 milliliters is the volume of all 4 of those pellets. I can use my mass data and my volume data to solve for the density of my unknown. The 4 choices are on the board in green, and you're going to have to compare your unknown. Keep in mind, you know from life, aluminum has a silver color, tin is a more silver, dark silver color, nickel is like a nickel, and copper looks more like a copper penny. So if your metal doesn't look copper in color, it's probably not copper if you see both of those volumes are close. Thank you.